my name is Masnya Azan Akia, and I will be the lecturer for the first half of the machine design course. Okay, so first of all, I would like to apologize to everyone for the delay of this online lecture because preparation takes a lot of time. Okay, so anyway, this first video session we will be looking into the brief overview of what machine design is all about. Okay, take a look of any product around you which have some mechanical features. Mechanical features means that it has some movement with some very specific function. Okay, like this angle transmission system and this robotic arm. Okay, that's a very big example. A simple household appliances like the washing machine and your fan and a very simple can opener are examples of product with some mechanical functions. Okay, now the exoskeleton of the Iron Man suit. Oh, that one is epic, man. It is an excellent example of product with a lot of mechanical function. Now, if you take apart the components of the product, you will notice that it is made up of assembly of multiple components. If I take apart the engine of a car, you can see the shaft, the gear, and the belt. If I take apart the can opener again, there are some gear system and a shaft. These components are the common machine elements which make up most product with mechanical function. So, the study of machine design is about the study of that machine element. We wanted to know what is the function of common machine element, what is the stress magnitude subjected to that component, and does that stress level exceed the limit of the component's material. What happens if the stress exceeds the stress limit of the component's material? Pecahlah, the component will fracture, rosak. And what happens if the component fracture? Products will not be functioning anymore. So, as a good designer, we have to avoid such damage by considering the factor of safety. When you want to come up with the design of a new device, you have to consider 3 items. The first one is, what is the function of that device? The second one is, what is the specific design requirements? The third one is, what is the evaluation criteria? So what's the difference between these 3 different items? Okay. The function of a device is a non-quantitative description. No numbers, no whatever. It's just a very generic description on the product's function. For example, the function of the device is to lift load or to transmit power or to grip the material. The second requirement, which is the design requirement, is a quantitative description. This time around, you have to supply the statement with some valid measurements. For example, the weight, what is the material to be used, and what are the components feature, and what is the specification of that particular machine element, such as the revolution per minute. Okay, the third criteria, which is the evaluation criteria, is a qualitative description. This time around, you have to give a specific characteristics on how you want to decide for the best design. For example, your decision making process requires you to select a device with the lowest cost or the highest performance or the fastest revolution per minute. Okay, let's look at an example. In this example, you are required to design a speed reducer as part of the power transmission of a small tractor. So basically, the engine of the tractor can operate at a very high speed. But because the tractor is quite heavy, then you need to make sure that the wheel rotates more slowly but at a higher torque because more work is needed to, let's say, move the tractor. Okay, so in order to do that, you have to design a speed reducer. So this is an example of how a speed reducer looks like. So basically, this part is the input shaft, which is connected to the engine motor, and this part is the output shaft, which are connected to the chain connected to the wheel drive, which moves the wheel of the tractor. Let us elaborate the specific function of the speed reducer. Okay, number 1, we want it to be able to receive power from the tractor's engine through a rotating shaft, as shown. Okay, and the second one, we want the speed reducer to be able to transmit the power through machine elements that reduce the rotational speed to a desired value. The third one is we want the speed reducer to be able to deliver the power at the lower speed to an output shaft that drives the wheels of the tractor. So these are three generic descriptions which describes the function of that speed reducer. Now, let's look at the specific design requirement of this speed reducer. Okay, remember the design requirement requires some quantitative value to support the description. Okay, for example, number 1, we want the speed reducer to transmit 12 kilowatt of power. So 12 kilowatt is the quantitative value. Okay, the second one, the input is from 2-cylinder diesel engine, the tractor's engine, with rotational speed of 250 radians per second. So 250 radians per second is the quantitative description. Okay, the third one, we want the output delivers the power at a rotational speed, at a lower rotational speed in the range of 35 to 30 radians per second. So that range from 35 to 30 is the quantitative value, okay, which describes the specific design requirement. The fourth one is we want the speed reducer to have a mechanical efficiency greater than 95%, and finally the minimum output torque should be at least 350 Newton meter. So as you can see, all the description in design requirements are more detailed and more specific, and it gives a very factual data. Evaluation criteria, on the other hand, are specific characteristics on how you want to assess your device or your product. For example, for this speed reducer device, we want to assess it in terms of its safety and also its performance. Is it easy to be manufactured? Is it easy to be serviced, or is it easy to be repaired? We want it to have a low initial cost because we don't have budget, tak ada duit, and we want it to have a low maintenance cost. Okay. When you are confident with your device function, its design requirements, and also the evaluation criteria, then only you can come out with the conceptual design by incorporating the use of multiple machine elements such as the shaft or the gear or the bearing. Okay, for example, you definitely need a shaft as an input shaft to connect it with the engine's motor. So you have to define that the rotational speed of the shaft to be 250 radians per second. Okay, and then you have to attach a multiple combination of gear to the shaft. So when the shaft rotates, the gears also rotate. So there is one smaller gear connected to the input shaft, and then there are another gear connected to gear number 1, which have bigger diameter than gear 1. Okay, so when you want to design the device using gears, in the future chapters, you will learn how gears with different diameter and different number of teeth will affect the power transmission of the system. Okay, so for example, if the smaller gear is connected to the driving shaft or the input shaft, then the output torque or the gear with the bigger diameter or more number of teeth will have lower speed and higher torque. Okay, so that is how you control the speed of a system by using multiple combinations of gears, which you will learn in the future chapters. Okay, so gear 2 is connected to the gear 3 with the shaft. Gear 3 is connected to a bigger diameter gear, which is gear 4, and the rotation at gear 4 will cause the output shaft to also rotate. So this output shaft will rotate at a lower speed, okay, because of the configuration of the gears. Okay, the output shaft is connected to the chain sprocket and it is connected to the drive wheel, and we want the speed to be 35 radians per second. So of course, all your conceptual design and design idea have to be supported with some legit and valid mathematical calculations. Okay, Another additional machine element that you can consider in the design of your speed reducer is the attachment of the ball bearing. So this ball bearing ensure that the system is statically determinate, the balance lah, so that you can measure the stress value of that particular configuration. You can also design the housing of the speed reducer, by which the inner part of the ball bearing should rotate, but the outer part of the ball bearing should remain stationary. Okay, that is all for now. I hope you enjoyed this introduction session. So in the next video, we'll be looking into the different material properties. Okay, so how does it relate with machine design? Why is it important in machine design? So I'll see you later in the next series. See you later, alligator.